But even the best border security won't protect us from what Mother Nature routinely throws our way. Of all our planet's upheavals, earthquakes are among the most terrifying. We can't predict them, and we sure can't stop them. But increasingly, engineers are learning how to protect against their awesome power. That's good news, because one of my favorite cities is also one of our most vulnerable, San Francisco. I'd always thought these skyscrapers would be the hardest hit in a big quake. But in fact, the taller the building, the more flexible it is. Skyscrapers can sway without falling over. What we need to worry about are thousands of buildings that went up before the 1970s. They're called soft-story buildings because their ground floor is an open space, usually a garage, with large doorways. In an earthquake, that structurally soft story can't support the motion of the upper floors, and it collapses. In 1989, a magnitude 6.9 earthquake damaged hundreds of these structures in the Bay Area and left thousands homeless. Today, throughout California's seismic zones, some 200,000 to 300,000 people still live in these death traps. They're sitting ducks. The risk is so high that cities across the state are writing laws requiring that these structures be retrofitted. But how can engineers figure out exactly what will work? Well, for starters, a 5-university team built a replica of a soft-story building from the 1920s. But they couldn't just sit around and wait for the Earth to move. They staged their own earthquake.
3, 2, 1.
Then they followed that with a devastating aftershock that brought this building to its knees. But we're getting ahead of ourselves, because before they flattened it, engineers spent a month testing ways to keep the structure standing. It's built on the largest outdoor shake table in the world at the University of California, San Diego. Powered by massive hydraulic pistons, this 172-ton brute can simulate the most devastating earthquakes ever recorded. It can also make a mean milkshake. Seriously, for team leader John Vandelant, this is the project of a lifetime.
This is the first time a building this size that represents a true soft-story building has been tested.
His team will test 4 engineering solutions that performed well in computer models.
We're looking at design and retrofit methods to try and make these structures safer for the many families around the United States that live in them.
The first retrofit involves panels of a new building material called cross-laminated timber, or CLT. CLT is made of lumber stacked at right angles and glued together, which makes for panels that are very strong and stiff. 2 sets of panels are placed on the garage floor and anchored to the ceiling. During an earthquake, they should rock in place and help absorb energy from the motion of the upper stories. But the CLT panels aren't bearing the burden alone. They're attached to steel rods that run straight down into the foundation.
The steel rods, that they have to transfer forces from the cross-laminated timber while it rocks, and this will dissipate the energy from the earthquake.
Before the test, they fully wire the place. 30 cameras and 300 sensors to measure the movement and behavior of each part of the building. Now it's time to rock and roll.
Loma Prieta in 10, 9.
This will be a simulation of the 1989 earthquake that took 63 lives and destroyed countless structures. But with its retrofit in place, this building's ready to rumble. Can just a few wooden panels really prevent collapse? The original earthquake lasted about 15 seconds. That may not sound like a long time, but if you happen to be inside a building that's about to collapse, it must feel like an eternity. Cameras reveal the CLT panels rocking in place.
Stop camera.
At last, the test is over. They head inside and look for damage.
Isn't that interesting? So that one, this one yielded.
It's clear that the panels saved the day. But the rocking motion put so much stress on the steel rods that they actually stretched.
This test was absolutely perfect. I'd say phenomenal. If this wasn't here, the building would have collapsed.
The researchers document every crack and break. Some repairs would be needed, but the building would still be livable. CLT panels are the simplest of the retrofits they'll test. Steel frames strengthened the openings on the ground floor and performed even better than the CLT panels, allowing minimal damage to the building. When engineers added plywood reinforcement on the upper floors, the steel frames kept the structure virtually intact. Same goes for the fourth retrofit, high-tech dampers that acted like shock absorbers on the bottom floor and kept the building standing. All in all, 4 for 4.
We've tested 4 retrofits to this point. They've done exactly what we wanted them to, sometimes even performed a little bit better than expected. All of these retrofits are a viable option.
That's great, but what would be the point of building a 4-story structure on a shake table and then letting it stand? So now, with all the retrofitting removed, there's one last test to run. Engineers have modeled this one in the computer, but they've never actually seen a soft-story building collapse. Until today.
So the 2 safe areas, it's back behind the red tape there, and then you can walk around the building and you'll see red tape over here.
For earthquake engineers, this is an epic event.
Running.
They start out with a few gentle shakes. Then they gun it, hitting it with an equivalent of a 6.7 magnitude shake. They watch as the second floor juts out over the garage level by nearly 1.5 feet. The engineers are shocked to see that it's still upright.
Wow, so 17% drift and it's standing. I guess that answers our question on how much drift these can take.
What will it take to bring this baby down? They hit it once again with a large aftershock.
100% MCE level in 3, 2, 1, running.
Wow. Unreal. Oh. Wow.
That made my day.
I don't think I've seen something like that.
The building they worked so hard to protect is just a pile of lumber, beyond repair.
I do have a soft spot in my heart for the building, but I know what we've done will provide engineering and science what they need to make these types of dangerous buildings much safer for the families that live in them.
Let's hope Californians apply those retrofitting techniques before the big one hits.